Something is very wrong with 3I Atlas, and the newest images prove it. What we're seeing now isn't just unusual. It rewrites almost everything scientists thought they understood about this object. Within the last few days, observatories from Canada to Puerto Rico captured details that shouldn't exist in any natural comet. Colors that don't match known chemistry, jets firing in directions that break basic physics, and a structure that refuses to fall apart even under violent forces. Whatever Atlas is, it's not playing by the rules, and the deeper you look, the stranger it gets. The first wave of shock came when the newest images started circulating between November 16th and 17th, 2025. Different observers, different equipment, different locations, yet every frame told the same unsettling story. Atlas wasn't breaking apart, wasn't fading, wasn't behaving like something that had just survived a brutal pass near the sun. Instead, it looked intact, stable, almost deliberate. But the real jolt came from what the cameras revealed in front of the object. A vivid, forward-facing jet, glowing with a reddish tint, shot straight toward the observer. At the same time, more traditional jets streamed backward in completely different colors, leaning toward greens and blues. Nothing in standard comet physics predicts a body choosing specific hues based on direction. Nothing explains why it would fire one jet straight ahead and others in perfect symmetry behind it. Every team that captured the object, from Canada's NEOSat to amateur astronomers in New Mexico and Puerto Rico, agreed on the same point. Atlas's structure wasn't fragmenting, even though those jets should have torn any normal nucleus apart. It was holding together as if something inside was maintaining its shape. And if the colors represented differences in chemistry or temperature, then Atlas wasn't releasing one uniform material. It was acting like a system with selective behavior. And this was only the surface layer of the puzzle, because once analysts started calculating what it would take to power those jets, the numbers became even more disturbing. When researchers dug into the numbers behind those jets, the entire conversation shifted. Natural comets rely on simple sublimation, ice turning into gas as sunlight heats the surface. But the power needed to drive Atlas's jets didn't match anything in that model, not even remotely. To stretch jets across millions of kilometers in opposite directions, the object would need to release material on a staggering scale. We're talking billions of tons over just a few weeks. That's a mass flow so extreme that even optimistic comet models collapse under it. And when experts tried calculating how much energy the sun could realistically deliver to an object of Atlas's size, the situation got worse. The numbers ballooned into the range of 16 to 18 digits, energy levels far beyond what a small interstellar body could absorb. In simple terms, for Atlas to produce this through heating alone, it would need a surface area thousands of times larger than what telescopes like Hubble measured. Replace carbon dioxide with water, and the math becomes even uglier. Instead of explaining the jets, the calculations shredded the idea that sunlight could be responsible. Then came another twist. The jets didn't behave like chaotic bursts from random ice pockets. They stayed tight, directional, and strangely stable, even as Atlas rotated. That kind of steadiness is the opposite of what a spinning, melting object should create. It suggested control, something fixed in space rather than tied to the rotation of the nucleus. And when scientists tried to force the numbers to fit a natural explanation, they only uncovered more contradictions. In fact, the attempt to keep the simple comet story alive exposed deeper issues waiting in the next layer of analysis. Once the energy numbers collapsed, scientists tried to save the standard comet theory by stretching it into something more exotic. Maybe, they argued, Atlas was built from strange materials. Maybe unknown ices or unusual thermal pockets could produce narrow, color-selective jets. Maybe the chemistry was rare, the structure unusual, the environment unique. But none of these rescue attempts held together. For the exotic comet idea to work, Atlas would need to maintain incredible structural strength while losing mass at a rate that should rip any natural object apart. No known combination of porosity, density, or thermal behavior can explain that kind of endurance. And even if we imagine some unheard-of mixture of exotic volatiles, they still wouldn't produce jets that ignore rotation and hold fixed orientation across enormous distances. Worse, natural comets don't create front-facing jets that glow one color and backward jets that shine in an entirely different palette. They don't selectively emit red forward and blue-green backward as if different processes were firing in different directions. Real comets behave like messy, chaotic snowballs. Atlas behaves like something with internal logic. Even the idea of complex surface fractures fails under scrutiny. If the jets came from random vents, their direction should drift as the nucleus turns. Instead, they line up like they're following a plan, not a rotation curve. By this point, scientists realized that every attempt to fit Atlas into the unusual but natural box required bending reality more than the observations themselves. The theory was becoming a patchwork of guesses, none of which explained why the object was so coordinated, so stable, and so selective. And once those explanations fell apart, researchers were forced to face a far more uncomfortable possibility, one that pushes the discussion into territory most people in the scientific community avoid. When the natural explanations started collapsing one by one, a small group of researchers stepped forward with a proposal that most scientists hesitate to say out loud. What if some of Atlas's features look engineered? Not alien invasion engineered, but structured, directed, intentional. Avi Loeb and others pointed out that several signatures in the data resemble controlled propulsion rather than chaotic cometary behavior. The sharply focused jets, the stable orientation, the way Atlas seems to maintain coherence under violent forces. These traits look less like random ice vapor and more like something managing its own movement. Some images even hint at metallic ratios that don't line up with normal cosmic bodies. Reports of nickel-rich plumes, especially those lacking the usual iron pairing, raised eyebrows across physics and aerospace labs. Industrial metals? Unbalanced alloys? Those ingredients aren't typical of natural formation, especially not in an interstellar wanderer. Then there's the acceleration. Atlas appears to drift off course in a way that suggests mass loss, but not the kind that leaves a debris cloud behind. It moves as if it's shedding material in a controlled, invisible way. That's the kind of behavior engineers study when designing low-thrust propulsion systems, not something comets demonstrate on their own. Even the shape of the jets carries a strange familiarity. Columnated streams that hold direction over millions of kilometers don't look like random geysers. They look like nozzles, the kind that maintain focus because they were meant to. No one is claiming Atlas is a machine. But the question is no longer dismissed outright. If an object behaves in ways consistent with engineered propulsion, the scientific method demands we test that option, not bury it. And just when that idea started gaining traction, an even stranger hypothesis emerged, something that breaks the boundaries of biology as we know it. Just as the technological hypothesis began stirring debate, another idea surfaced, one that sounds impossible at first, yet fits several observations better than the classic comet model. A few researchers in plasma physics and astrobiology suggested that Atlas might not be a machine or a comet, but something alive in a form we've never considered. Not life in the carbon-based biological sense, something far more unconventional. For years, studies on plasma structures in Earth's thermosphere have shown that under certain conditions, charged particles can self-organize into stable, glowing formations. They can form cores, maintain shape, and even react to electromagnetic fields in ways that mimic movement or intent. These aren't living creatures in the traditional sense, but they challenge the idea that life must look like cells, DNA, or organic chemistry. When scientists looked at Atlas through that lens, several odd behaviors suddenly aligned. Jets that stay fixed despite rotation could respond to magnetic fields rather than surface vents. The intense color differences might come from plasma variations instead of chemical reactions. The stable core, refusing to break apart despite massive forces, resembles certain plasma confinement behaviors. The shifting brightness and sudden bursts of energy echo what lab-generated plasma entities already do. The idea sounds radical, but it avoids the impossible energy requirements of sublimation and the engineered precision implied by propulsion. Instead of being a machine or a snowball, Atlas could be a self-sustaining plasma structure, something that drifts through space, interacts with energy, and behaves with a degree of internal organization. In that scenario, Atlas wouldn't be artificial or natural in the way we use those words. It would belong to a third category we barely understand, a form of life, or proto-life, built from energy, not molecules. And while this idea might sound like science fiction, it fits enough anomalies that researchers couldn't dismiss it. But the deeper they explored, the more they realized none of these hypotheses could move forward without something critical. Better data, sharper images, and measurements that could finally settle the debate. With three competing explanations on the table, exotic comet, engineered object, or plasma-based organism, the scientific community faced a problem they couldn't ignore. The available data wasn't enough to prove or dismiss any of them. Every hypothesis required sharper evidence, and the window to capture it wasn't going to stay open forever. The first priority was high-resolution imaging. Small telescopes and amateur snapshots had sparked the mystery, but now researchers needed crystal-clear views of the nucleus. They needed to see whether Atlas's core was smooth, fractured, metallic, luminous, or something entirely unexpected. One close-up could silence entire theories in seconds or confirm suspicions no one wants to say out loud. Spectrometry was next on the list. The unusual nickel signatures demanded independent verification. Were the plumes really rich in nickel? And if so, why was iron missing? That imbalance would be bizarre for natural formation, but perfectly normal for refined materials. Only precise spectral data could settle whether Atlas was venting minerals, plasma emissions, or engineered alloys. Then came the most ambitious step: dynamic monitoring. If the jet stayed locked in place regardless of rotation, it would crush the natural explanation instantly. No comet behaves like that, but a machine or plasma entity might. Tracking the orientation hour by hour could reveal whether the jets were tied to the nucleus or fixed relative to space itself. The boldest proposal was also the most controversial: a sampling mission. A probe capable of collecting dust or gas from Atlas's environment would end the debate decisively. But designing, launching, and navigating such a mission in time was a logistical nightmare. Still, some argued that if Atlas turned out to be engineered or alive, missing the chance to sample it would be one of the greatest scientific failures in human history. Finally, experts pushed for collaboration across fields that rarely interact. Plasma physicists, aerospace engineers, astrobiologists, planetary scientists. This wasn't a problem one specialty could solve. The mystery was too big, too layered, too strange. And while the world waited for answers, a new realization hit researchers everywhere. Atlas wasn't just displaying isolated oddities. When the anomalies were stacked together, the pattern became impossible to ignore. Just when scientists thought they had cataloged every anomaly around 3I Atlas, something happened that forced the entire investigation into a new, unsettling direction. On the night of November 11th, two radio observatories, one in New Mexico and another in southern Chile, detected a faint repeating pattern in the comet's direction. At first, the signal looked like ordinary background noise until astronomers noticed something impossible. The signal repeated every 11.4 minutes, with each pulse containing a triplet pattern, almost like a heartbeat echoing across space. What made the discovery even stranger was that the pulse only appeared when the comet's third luminous point, the eye, was facing Earth. The moment the rotation shifted, the signal vanished completely, only to reappear later with the exact same rhythm and structure. Researchers ran the signal through every filter, checked every satellite, every known interference source. Nothing matched. A geomagnetic anomaly? Unlikely. A glitch, ruled out by 2 observatories receiving the same pulse from thousands of kilometers apart. An unknown natural phenomenon? Possibly. But nothing in the known universe produces a stable, repeating triple pulse at a fixed interval, synchronized with a rotating comet. Even more disturbing, when the signal was slowed down and enhanced, the waveform formed a symmetrical shape resembling a triangular pattern with 3 rising peaks followed by a silent drop, eerily similar to the 3 eyes of Atlas seen in recent images. Scientists are now split into 2 camps. Team 1, it's an exotic plasma effect caused by cracks in the nucleus. Team 2, the structure inside Atlas is interacting with solar wind in a way we've never observed before. Team 3, the quiet team. They suspect it's not a comet at all, but they refuse to discuss their theories publicly. The only thing everyone agrees on is this: whatever Atlas is doing, it's intentional, or at least organized, and the timing of the signals is too precise to be random. And if this signal is a message, it wasn't meant for us. At this point, it's clear that 3i Atlas is far from ordinary. Every anomaly, every jet, every color, and now every mysterious signal pushes scientists into uncharted territory. The stakes are enormous. If Atlas is a natural but exotic comet, it will expand our understanding of interstellar chemistry and physics. If it's engineered, the implications are profound for humanity's place in the cosmos. And if it turns out to be a plasma-based life form, everything we thought we knew about life itself must be reconsidered. The immediate next steps are straightforward but challenging. High-resolution imaging can reveal the nucleus in unprecedented detail. Targeted spectrometry may confirm unusual metals or chemical imbalances. Continuous monitoring of jet orientation could reveal patterns impossible to explain naturally. And in the far future, a sampling mission could finally settle questions that now hover between science and speculation. Experts emphasize one principle above all: keep an open mind without abandoning skepticism. The data will speak, but only if the right instruments are watching. Any premature conclusions risk either dismissing the extraordinary or turning legitimate science into sensational spectacle. For the public, the lesson is just as urgent. Transparency, curiosity, and attention to verified updates will allow everyone to follow the process, not just the headlines. In the coming weeks, new images, calculations, and observations may flip everything we think we know about this visitor from another star system. So what do you believe? Is Atlas an exotic natural phenomenon, a technological artifact, or something stranger entirely, a living plasma entity drifting silently through space? The answer isn't here yet, but the chase has just begun. Stay observant, stay curious, and watch closely, because whatever Atlas is, it's about to teach us more than any comet ever has.